The vast grazing lands of the Texas Panhandle provide the perfect place to experiment with measuring methane emissions from cattle. Here's Rick Todd, a research soil scientist from the USDA Ag Research Service at Bushland, Texas.
Well, our goals, first of all, were to understand the magnitude of methane emissions from grazing beef cattle. Second, we wanted to get an idea of what the factors are that influence those emissions. And finally, we wanted to test out different ways that we could reduce emissions of methane from grazing beef cattle.
Why is methane a concern? Methane emissions contribute to greenhouse gases, which trap heat in the atmosphere. Of all greenhouse gases, methane makes up about 16%. Of that 16%, 1/4 comes from beef cattle, primarily through belching, and most of that, at 85%, comes from grazing cattle. The first question is how to actually measure the gases released by the grazing cattle.
So we really face several challenges in measuring methane from a grazing cattle herd. Because cattle are essentially mobile point sources of methane. So the methane's, they're eructating, breathing out the methane from their mouths and their nostrils. And they're moving around as they do that, as they graze, as they go to water, as they loaf, as they bed down. So we had to come up with a new approach to using our open path lasers.
3 laser towers like this one were spaced out to crisscross a pasture at the Bushland site.
Remember, the cattle are mobile, so we had to know where they are. So what we did is we put collars on them, and on that collar was a GPS unit.
With the lasers shooting across the pasture, they can measure downwind and upwind concentrations, run those numbers through an atmospheric dispersion model, and calculate methane emission from that herd. Now let's leave the pasture and head inside for a different methane experiment, this time using specially built respiration chambers for cattle.
Well, the respiration chambers give us a chance to very, very accurately measure methane production and carbon dioxide production from animals under ideal conditions or when we know exactly what the feeding conditions are.
Retired research animal nutritionist Andy Cole describes how they use the chambers.
We put the animal in the chamber here for a couple of days. While they're in here, we're collecting all the feces and urine they produce. We're also pulling air through the chamber, and by measuring the gas concentration for methane, carbon dioxide, and oxygen in the air coming in and the air going out, we can calculate how much methane and carbon dioxide the animal produces from normal metabolism.
With the exacting conditions of the chamber, researchers can see that this much forage equals this much methane output per animal per day. With information gathered from both experiments, scientists are able to refine best management practices for grazing cattle and get to that goal of reducing methane output.
Our ultimate goal is find out how much methane is produced, not just per day, but also per unit of production. Because when we increase animal productivity, we decrease the number of days that they have to be on pasture or that they have to be in the feedlot to get to their final body weight. So we may actually, although methane production per day might go up slightly, methane production over the life of the animal or per unit of production goes down, and so we become more environmentally efficient.
The pasture beneath those cattle is also a source of methane emissions. USDA research soil scientist Breck Monks works on that part of the methane puzzle. She finds atmospheric methane through soil sampling.
Today is just a normal day for me at Marina. I generally sample on an every 2-week basis, which is fantastic. And we're going to be soil sampling, we're going to be taking grass samples, and we're also going to be taking greenhouse gas samples from stationary chambers today.
These stationary chambers look at methane at a microbial level.
A soil microbial perspective and how, whether soil microbes are creating a lot of methane and releasing it to the atmosphere, or whether there's soil microbes that are taking it up out of the atmosphere and turning it into another product.
Research will continue looking at the complicated balance of microbial methane and how that impacts beef production. The ultimate goal is finding the most accurate information, which will be used to form policies and fine-tune management practices for beef producers.
We don't know what policies, regulations, consumer preferences are going to be. That's kind of an unknown. But what we can provide producers of cattle on the southern Great Plains is the best science-based information we can, so that when the time comes when real decisions have to be made, that those decisions can be based on science.